Hello students, this is Mr. Lesage and this is a tutorial on Math 6, specifically on ratios, but it's from the Rate, Ratio, and Proportionate unit in the Math 6 course. Several of my students are having trouble with these kinds of problems, trying to figure out how to write the appropriate ratio. Let's look at this first problem. The Bears have won 7 and tied 2 of their last 13 games. They've not forfeited any games. So what we want to find is what's the ratio that correctly compares their wins to losses. Let's go back and review what is in the problem here. We can see that they have won 7. I'm going to highlight these so we can see them. They have tied 2 games, and we're looking at their last 13 games. So if we think about those games, 7 of those were wins. So there are those 7 games. Then we had 2 that were ties. So altogether now we have 9 games accounted for. So that means that we must have had 4 games that were losses. So here are the wins, here are the ties, here are the losses. We're supposed to construct a ratio that compares wins to losses. So the number of wins we can see clearly is 7, and the number of losses is 4. So we can write our ratio 7 to 4, or we could write it as a fraction 7 over 4. Let's look at the second problem, the donut problem. Here a student has brought 24 donuts to a class party. I have a feeling that's going to be important information. Half the donuts had vanilla frosting with sprinkles, 2 had strawberry frosting with cream filling, and the rest had chocolate frosting with sprinkles. What fraction of the donuts had sprinkles? And just a reminder, there are 12 donuts in a dozen. So we started with 24. Half of those had vanilla frosting with sprinkles. 2 of them had strawberry frosting and cream filling, but no sprinkles on these. And the rest were chocolate frosting with sprinkles. So there are the key pieces of information. Let's go back and check the question now. What fraction of the donuts had sprinkles? So we know that in total there were 24. So when we do our ratio, we're going to have a number compared to a second number. We'll put it in a fraction ultimately. But the total donuts that were brought were 24. So that number will go here. Now we're looking for the number that had sprinkles. Well, these, the half that had vanilla frosting and sprinkles, are going to be in that group. And then the rest had the chocolate frosting and sprinkles, so the rest of what? It's the rest of the second half minus these 2. So for 24, the first half would be, let's go over here, the first half would be 12. There were 2 that didn't have cream filling out of the second half, second half would also be 12. So 2 from that second 12 leaves 10. So 10 must have been the ones that were chocolate and sprinkled. So that total then is what would go here, and that's 22. And our fraction would then be 22 over 24, 22 24ths. We could also reduce that by dividing both numbers by 2 and saying it's 11 twelfths. All right. Let's look at this problem. Mr. Cole had 30 students in his class. He has twice as many girls as boys. And what we want here is the ratio of boys to total students. Now, my guess is a great number of students who read this will get this far. They'll say, Mr. Cole has 30 students in his class. He has twice as many girls as boys. What's the ratio? And they would say, well, the ratio is 2 to 1, 2 girls for every boy. But that's not the question here. The question is, what's the ratio of boys to total students? So we know that the total students is 30. We know that from this part of the question right here. He has twice as many girls as boys. We actually have some numbers that are pretty easy to work with here. If there are twice as many girls as boys, that means there are 3 equal amounts of students. 2 of those amounts would be girls and 1 boys. So that means that the girls would equal 20 and the boys would equal 10. So now there are twice as many girls as boys. So the number of boys we see is 10. And remember, we're comparing this to the total students, which was 30. So the answer for this is 10 to 30, 10 compared to 30. Or, again, we could reduce this down to 1 to 3, or 1/3. Finally, let's look at this bottom question here. Here we have a diagram, and it shows a rectangle that's divided into equal parts. There are 1, 2, 3, 4, 5, 6 parts. What they want us to find is the ratio of unshaded sections to shaded sections. So let's highlight that. We're finding the ratio of unshaded sections to shaded sections. I can't bold that because it's an image there. So the unshaded sections, 1, 2, 3, 4, 5. So I'm going to put the 5 here, and the 5 is going to go there because it's 2 shaded sections. Oh, unshaded to shaded. I'm sorry again. Need to read carefully, like I tell my students to. So the unshaded to the shaded. Unshaded is 5. And the number of shaded sections is 1. So our ratio is going to be 5 to 1. Again, I suspect that many of you, when you look at this problem, you might not even read all of this. You would look and say, oh, this is 5 out of 6 or 1 out of 6. And that's not what they're asking for here. They're not asking for the shaded or the unshaded compared to all the sections. They want the shaded sections compared to the unshaded sections compared to the shaded. I hope that helps. Be sure and read these questions very carefully. Within your software, within the Edgenuity software, you know you have highlighting capabilities, and it might be a good idea for you as you go through these to highlight key pieces of information like we did. All right, good luck. I hope that makes this section of Math A a little easier.